Hello, welcome to my pantry. Today I'm going to be covering over the different types of mixtures that we cover in this chapter. So here I have a solution, which is homogeneous. So this is made up of salt and water. So this is a solution because the sodium ions and the chloride ions dissolved within the water range from about 0.1 to 1 nanometers. So if in the solution you can see that the particles don't settle, they remain suspended indefinitely. Another characteristic of solutions is that it doesn't scatter light well. The particles are too small to do this. So next, I have a colloid, which here is milk. So colloids are distinguished because the particles that are dissolved within the solvent range from about 1 to 1,000 nanometers. So in milk, we have proteins called caseins and little fat globules. So the casein proteins range from about 205 nanometers, and the fat globules average about 434.6 nanometers. So like a solution, the particles within the milk do not settle, they remain suspended. But what makes this interesting is that it'll actually refract light because the particles in this little mixture are large enough to do that. Finally, I have a suspension of flour and water. So the particles in the suspension are greater than 1,000 nanometers. So the flour particles here are about 2,120 nanometers. So they're so large, that means they have to settle at the bottom. And then, like a colloid, suspensions refract light because the particles are large enough to do this. Finally, to finish up, I have another example of a colloid, which is Jello. So what makes Jello Jello is that they're actually gelatin particles dissolved in water, and these are left to solidify, which makes the Jello. So gelatin particles are about 168 to 460 nanometers. So they fit within the colloid range. Now the fun thing is, in the colloids and suspensions, the refraction of light I was talking about is called the Tyndall effect. So let me just demonstrate this in Jello real quick. Get the flashlight. And then so if you can see that little beam of light traveling through the Jello, that's called the Tyndall effect. So the light particles are actually bouncing off and being reflected from the particles within this Jello. And that's why we can see that beam of light. Now, if we were to do this in a solution, we wouldn't be able to see it as well because the particles just aren't big enough to refract the light. So thank you for watching. I hope you like this little demonstration. Bye. Oh, right. Extra addition. So the secret bonus word is meniscus. So the meniscus is actually the little membrane that the water forms because of the adhesion to the outer sides of the little container. So the meniscus that the water forms is called a concave meniscus because of the concave shape that it makes. The mercury makes a convex meniscus because it makes this shape.